Hey, welcome back, students. I want to go ahead and take some time to speak with you a little bit about isotopes. I want to go ahead and define them for you as to what an isotope really is and how you can identify them. I also want to go ahead and introduce the concept of isotopic notation towards the end of this video. But overall, I just want to briefly address what an isotope is and just going to give you a broad overview of how you identify them, what it really means, and what it looks like in terms of representation. Okay, so let's go ahead and get started. Let's look at what an isotope really is. And so let's begin with the following question. What is an isotope? Well, an isotope is going to be the following. An isotope, so let me just write this down. An isotope is nothing more than any atom. It's an atom with a different number of neutrons in the core. And so it's an atom with a different number of neutrons. A popular example that I give at this point in the course or at this juncture in the lecture is I usually talk about hydrogen. Now I use hydrogen only because it's a very small atom, it's very popular, easy to identify because it's got the proton number or the atomic number of 1, and so here's hydrogen. Okay, and so if I go ahead and develop the element tile for hydrogen, we know that the symbol is H. It's got a proton number of 1 and a mass of 1.008. And so from here we can generate the pen count. We know that the pen count is equal to 1 and 1 for the proton and electron, and then if we deal for the neutrons, it's going to be 1 minus 1, which is equal to 0. So we usually use this information here as a way to identify it. And so this is the most common form of hydrogen. So this is the common form of hydrogen. But what we don't often talk about are the other forms of hydrogen. And hydrogen has three versions or three different isotopes. Okay? And since we know that an isotope is an atom with a different number of neutrons, what you can expect here is that you're going to have a different set in neutron number. And so let me show you that here in a second. Let me go ahead and erase some items here to make some room for us. And so here's the isotope. Let me write it again. And so for hydrogen, what you've got is you're going to have a hydrogen, which we'll denote this way. We'll put the 1 on top and the 1 on the bottom. I'll explain this in another video, but for right now, I will briefly say that the top number here is going to be the A number, and the bottom number here is going to be what we call the Z number. Okay, and so I'll just reference that now just so that we'll get that out of the way. Another version of hydrogen is going to be hydrogen with an A number of 2 and a Z number of 1. And the third version of hydrogen is going to be the one with a number of 3 and a Z number of 1. Keep in mind that the A number represents mass and the Z number represents the atomic number or the proton number. Okay, and so So if you look at these different atoms here, or representations here, what you're going to notice is that there is a difference among these. First off, you notice the Z number for all of these here, these numbers at the very bottom, these are the Z numbers. But notice that each of these Z numbers here, they all look the same. They're all 1. There's no change here. And the reason you don't see a change is because hydrogen is hydrogen is hydrogen, which means it's got the same number of protons for each version of the atom. The proton number does not change, okay? But on the top, for the A number here, you're going to see that there is a difference here between the 3 atoms. Notice the 3 at the very top. These numbers here represent a difference in mass. Notice that the first version of hydrogen with a 1 and a 1 has a mass of 1. The second one here in the center has a mass of 2, and the third version of hydrogen has a mass of 3. Because they each have a different number of neutrons, they're going to have different masses. Now, how do we find the number of neutrons? Well, you simply take the A number, subtract the Z number. So you take A minus the Z, and that'll give you the N. And so in this particular case, if I go ahead and do that number here at the bottom, let me just separate this out here. And let's take an N number here for the first case. The N number at the bottom, 1 minus 1, is equal to 0. And in the second case, 2 minus 1, that'll give me a 1. And in the third case, 3 minus 1 will give me a 2. So you notice that each of these atoms here has a different number of neutrons. The first atom is what we normally call the stable version. and that would be the first version over here at the far left. That's the stable version of the atom, and because it's the stable version, it has the normal name. It's called hydrogen, and we find this on the periodic table at position 1. But the other two atoms here, hydrogen with a mass of 2 and hydrogen with a mass of 3, these have different names. And those names are deuterium for the second one, so we'll do this one here, deuterium, and tritium for the last one. Just a little bit of FYI for you, okay? But notice here, these are 3 different versions of the hydrogen atom. Each one has a different number of neutrons. As such, each of these is a different isotope of hydrogen. In the next couple of videos, we're going to go ahead and talk about isotopic notation, what it is, and how we calculate it.